Is log into Drive folder called artificial intelligence. Inside that we have lead regression. Log into a Drive, data is also there, code is also there. Run both the file. It's only one file and data file is there. Just run this. You will be getting error for TensorFlow. Make sure you install this package. TensorFlow, which is an approximate 450 to download. My students done for you. नहीं हो रहा है। Just run below all the code stages. Rishabh, getting error for all the codes? Right. ठीक है. Triple nine, sorry, वो 5599999955. Online students, are you getting an output for this? Or getting error? नहीं आ रहा. आपका भी हो गया? दिखाओ. इंस्टॉल हो गया कैसे? वही देखना. ये हो गया ना ऊपर वाला? हाँ तो हो जाएगा फिर. रुक जाओ. ये हटा दो. डन फॉर यू. आपका रन हो रहा है ना? 3 people done. Gayatri. Done. The main thing is TensorFlow has to be installed properly. How many are remaining? 1, 2, 3, 4, 5, 6, 7. Download नहीं हुआ. Done नहीं. pip install TensorFlow download हो गया. अच्छा वही रन. लगा देते दो. आपका हो गया? महेश वहाँ पे नेटवर्क नहीं आएगा कुछ रहता. तो डेटा में एक कॉलम में रो है जहाँ पे ब्लैंक है पूरी रो, रो को डिलीट करो, रो डिलीट करना है। एक online students just wait for a second, classroom students are getting some error. Okay. Guys, will do a small revision meanwhile. So how many are still remaining for downloading? TensorFlow 1, 2, 3, 4. So guys, in neural network, an artificial neural network, how many layers we have? Input. Hidden. What is the difference between input and hidden? Input layer will take data. So we have your X1. Whatever you pass, always give the data in scale format. If you do not give in a scale format, TensorFlow convert into scaling. Second point, we study weights. What is the use of weights? To identify which variable is highly influencing your Y variable, or which variable is most important. Okay. What is the range of weight? Okay. Then next, what we studied? What is the use of bias? Where zero? Summation means cell body may. To control cell body should not become zero. That's the reason we use bias. Bias is not for neurons. Bias is not for any other things. It's only for cell body controlling. Always values 1. नहीं वो डबल लाइन नहीं है लैपटॉप में कनेक्ट करो ना ठीक है then we have hidden layer मुझे दो वहां तक तो नेटवर्क नहीं पहुंचेगा वो No, what's 511 555 185. The नाम क्या है? वाईफाई का नाम क्या है? प्रॉब्लम है वाईफाई बंद करने का एक्सेस में ब्लॉक करके रखो। हाँ सर। वहाँ कैसे कर लेंगे ठीक है आराम से पासवर्ड बैठना कभी हो गया महेश next so we have seen x1 x2 we have weight we have bias then we have hidden layer how we decide the number of hidden layers no. X minus 1 in each hidden layer how we decide the number of neurons maximum can be anything minimum has to be equal to x that is for neuron in each hidden layer this is only for hidden layer so yeah we can say that number of hidden layers has to be x minus 1 number of neurons has to be minimum should be x maximum can be your finite how much you want to give it what is the use of neurons for calculations neuron is used to take all the input and do a calculations okay inside neuron we can also use what is the use of dropout to reduce the complexity okay then we have cell body is a combination of summation and activation function how many activation function you have written yesterday linear logistic sigmoid something 10h 10H पे लिखा होगा ना कुछ डायग्राम, 3 डायग्राम टॉप. हाँ 10H. So guys, the famous linear sigmoid 10H, which is called hyperbolic 10. They are famous, which is used, and the last one is ReLU. So they are famous activation function. Okay. In the first case study, you will be only seeing the first activation function. When we keep on increasing the level, we'll see different activation function. What is the use of activation? To determine the output. Output is nothing but prediction. Clear. Then we have point number 4, which is called as error, also called as loss function. Guys, in an interview, sometimes people ask you what is the loss function of linear regression. So it's RMSE. Sometimes they ask you loss function of logistic regression. Logistic is regression task or classification. So read the loss function there in classification. Sigmoid is not a loss function, it's a binary cross entropy. That is a loss function for logistic regression. And to update weights, we have how many methods? To reduce error, we need to update weights. We have gradient descent, stochastic gradient descent, gradient descent. I'll just give an example how gradient descent worked, okay, at overall level. Just a hypothetical situation, okay. Can I say in linear regression, beta naught and beta 1 are the most important part? Any wrong in beta? Wrong in your prediction? If prediction is wrong, can I say that error increases? Okay. So beta naught, beta 1 has to be accurate. I just have taken a small scenario, guys. I've taken X and Y. Will stand for ordinary least square method, which we use in linear regression. The beta naught, beta 1 formulas. First, I have written assumed beta naught value as 1, beta 1 as this I have assumed for myself. Then we start a journey. What is the prediction equation? This one. How much is the error? 0.4. Then if you see second row 0.9, third row 2.2. I just computed the SSE, sum of squares of error. First we compute error, then we compute square. I have done that just a sum. Okay, just a sum. If I compute average, it become mean square error. Clear? Now, I'll keep on changing the value of my intercept. I'll keep on changing the value of my intercept. Let's say I'll take 0. How much is the error? Let's say how much? I'll take slope as 0.2. If it increases, decrease. If I take 0.4, 0.6, 0.8, 1, again decrease, 1.2. See the difference? When I say 1, it's 0.45, 1.2. The numbers are increasing now. So I have written for every intercept value, I have their error. Where we have the smallest error, 0.45. So what would be the best value for beta naught? 1. This concept is called gradient descent. You will find the best value of your intercept, and that best value is used for prediction. Still clear? Any question you have, can say. Have you seen this diagram anywhere? So where we have the smallest position, if you can see, at this point of time, over here. Here we have the lowest error. I just draw the diagram for this. Sometimes this diagram is called bias variance trade-off. Trade-off, where we have the lowest variance. Clear? Now the way I change my beta naught value, okay, let's try with beta 1 also. This is not random try, guys. At the backend formula is there to update every values. Okay, I'm just taking a scenario for you. So 0.64 in this combination is best for us. Example, okay. Let's try 0.8, 0.2, see how much iteration software will perform for you. Your errors still keep on increasing. So can I say in our case, this combination is best for us? Still clear? In backend, the calculation will happen. So I just explain you how scenario will change for you. Okay. Guys, any question in the process flow of this, please ask. I'll repeat again. Because this flow you will not able to see on like a diagram format which we have drawn. Software will just give you the computational. Clear for everyone? Neuron is just a calculation of weights and input. No, calculations. Calculation and summation. X minus 1. अगर 10 x वेरिएबल है तो कितने हिडन लेयर्स बनेंगे? 9. वो है x minus 1. तो हिडन लेयर 1, हिडन लेयर 2, हिडन लेयर 3. तो हर एक हिडन लेयर्स में कितने वेरिएबल्स होंगे? मिनिमम 10 और मैक्सिमम 100, 200 depends on you. That happened. Weights are different because every neuron, every variable of getting weight is different. हर वेरिएबल को हम हर एक कॉम्बिनेशंस में ट्राई करते हैं. न्यूरॉन का काम है कैलकुलेशन को स्टोर करना. ये उतना ही जॉब है उसका और कुछ नहीं. आज आप कैलकुलेशन करोगे मल्टीप्लाई एंड समेशन, यू नीड टू स्टोर समवेयर द आउटपुट. दैट टाइम वी यूज न्यूरॉन. Okay. Now, guys, this entire scenario, artificial intelligence is invented in 1952 by one creator. So let's take a small scenario. You are at home and you are at your restaurant with your friends. Okay. Or some unknown person beat you. Okay. First scenario. Second person, your dad beat you. Okay. You are the action is equal. Both are beating you, but the reaction change. Agree? You know? Okay. So same way, guys, the input comes for you, the output will change. This to your mind, how your brain bifurcate. Okay, who is he or who is he? Like this way. That bifurcation make people more curious. That's the reason artificial intelligence is invented. Artificial intelligence is nothing but a human brain. Scientists inspire from the human brain. That's the reason they invented. Because the input is same, but the output is different. How they finalize that they are different output. That finalization is done based on weights. Okay, when unknown weight, the weight is very high. Okay, and that weight, the weight is equal to 0. So clear. Y minus Y hat. Actual minus prediction. Okay. We have written various loss function. Okay. If you're working on linear regression, we can use RMSE, MSC, MAE. That is our loss function. Okay. If you're working on binary classification, you can use binary cross entropy. Everything have their own formulas, guys. Okay. RMS is Y minus Y hat. That is for error. Here cross entropy have different formulas. Okay. Multi-class have different. So interviewer will ask sometime the formulas of this entropy is also loss function also. Okay. You can search the name in Google and you can get the formulas also. If you want, I'll search and give you. Finally, in loss, no? Achha, the cross entropy here. This works on 1 minus log of 1 minus pi, probability of y prediction. So every form, there is a, if you go to analytics with there, all the formulas is available. Calculation is not there. They only give the formulas over there. I'll open just a reference for you. Also, there are LMS notes. This is the formula. This is for multi-class. Here we have binary multi-class cross entropy loss. Binary cross entropy. This is a normal one. Shall I move forward? आपका हो गया? Point number 1, prior guys, what happened? Need to explain Seaborn, NumPy, Pandas. Okay. So TensorFlow was the package invented. There are two different packages. TensorFlow is separate. Keras is separate. And to run this too, we required some graphic processor. We call NVIDIA. Then we have we have GPT now. Also we call GPT. We also have that. Then we can use GeForce. Okay. Their graphic processor to run the query, a very large query. So what will have in separate install for TensorFlow GPU, then normal laptop GPU. So lots of installation is there. So what they have done, they have combined all the things in one package. That's the reason the package size is 450 MB. Okay. So TensorFlow is TF. From TensorFlow import function, Keras. Okay. From Keras, I need layers. Okay. Now, why we call this as layers? How many layers we have? Just one second. Light off. So guys, here we have a layers. So first we have input. We have hidden, and we have output. Can I say first the data will pass from input to hidden, then input hidden to output? So can we call they will follow sequence? So they are sequential process of data flow. Plus we have layers. That's the reason we install layers. Pre-processing means you can apply scaling, replacement of missing values, outlier, that is called as pre-processing. So first I import the data, which is your automobile industry data. Our objective is to predict the mileage of a car. This MPG stands for mileage per gallon. Okay. Whereas other variable is your X variable. Okay. We check info, how many rows we have, number of columns, 8. Need to explain these queries nowadays? Thank you. We check missing values. Do we have? What's power? 6 rows out of 398. How much percent? So can we delete? Okay. Can we replace? It is our decision what to do. When we have few number of rows. Akash, stand. नहीं आप ठहर जाओगे तो so we okay. So we have less row missing. In my case, guys, I'm dropping it. If you want to replace, you're allowed to replace also. Now, if we have horsepower this data, you will replace with which number, which method? Why mean? Why not median? हाँ तो check किया ही नहीं आपने तो mean कैसे कर? So always check, do we have outliers? If outlier present, go with median. If not, go with mean. So I just remove that. Okay, how many number of rows we have now? 19. So 6 rows has been deleted. Okay. Now we have a data called as origin. Okay. Origin defines from where you have purchased it. Okay. So I'm replacing 1 by US, 2 by Europe, and 3 by Japan. So here we have a category data now. So as per the rule, guys, linear regression should use numerical data, because while we are solving on pen paper, if you have seen, we have take mean of X. Okay. So here we cannot compute mean. If your manager or your business want to use category, then we need to convert into numbers. Otherwise, my preferable, do not use category data. Okay. If business need, you have to use it. So PD dot get dummies, data set, prefix and prefix separator. Means I don't need the name origin and underscore. I just need the name Europe, Japan, and USA. Need to explain this, how we are getting 1-0. What is the difference between label encoder and dummies? Hmm. The dummies works for row wise, label encoder for one column. Here we are splitting it into two parts, train and test. Okay. Sample data set. Sample is the function with the ratio fraction of 80% in training. Random state as 0. Assigning in train data set. Remaining data will come in test data set. This is called as a pair plot. This is a visualization of MPG versus all other variables. You may have done in your last test something known as cologram. This is cologram only. What is the first variable name? MPG. So this is histogram of MPG. Look like bell shape. Close to. Okay. Next, this column is MPG. Now from the bottom, what is the column name? Displacement. Cylinder, displacement, and weights. If I go and check for displacement, this is your displacement. What type of relation we have? Negative correlation. So pair plot is a combination of histogram and scatter plot. Easy to clear, guys. Concept here, how to read it. Okay. If I need to check a correlation between MPG and weight, what we have? Weight and displacement. Positive. Till you clear? So this is for weight and displacement, and this is for your weight and MPG. We just have the normal describe function, your count, mean, median. Okay. Transpose this row become column become row. Now we have taken from the train data set, just making a copy called train features. Just a copy, fix your safe inside. What is the pop function? To delete. So deleting which column? MPG. From which data set? Train fees. And keeping in train label. So can I say that train label is my y variable now? So delete किया है. So कहाँ save कर रहे हैं हम? Train label. Deleting from where? Train features. So train features will have all X. You can see. Do we have anywhere MPG? So train features have independent variable and train label have dependent variable. Clear? I say pre-processing. I want to do normalization. Normalization is nothing but your Z-score scaling. Assigning in normalizer. It's a function now. We have not applied it in data. As I said, guys, TensorFlow works on always arrays of data. In arrays means you're only working on NumPy. When there is a small calculation, we use NumPy. When we have a bigger computation, we use TensorFlow. Train features have all X, converting into array, applying normalizer. I'm just giving a display for you. This is your original data. And this is your normalized data. That's a print function. Now, method number 1, linear regression. Okay, this regression is without hidden layer. If you want to write linear regression without, if it do not have hidden layer, what we call that as? Just see the theory. I have made you draw the diagram without hidden layer. Just go back and see the theory. Single layer perceptron. Okay. On screen. Guys, can I say that in input here we have train features as my X and train label as 1. In train features, how many X we have? So can I say we have this one 9 input? Here we have 9X. So input layer will have 9. Is it clear? And output layer will have how many? 1. So output layer always will have only one neuron. Hidden layer has many neurons. So the difference between hidden and output is output layer always have one neuron, hidden has many. I want to use Keras. Want to apply sequential. First, I want to do normalize layer with dense. Dense means we need to decide the neuron. Unit as 1. 1 means I'm talking about only output. Okay. So example, here we have this input. We'll multiply with weights, cell body, activation, and output. Till clear? Do we have anywhere hidden over here? What is the activation function? Bias value. Assigning a model and give me the summary. This is a calculation we'll read later. Okay. Now we have to update weights also because we want error has to be low. Linear model, I'm compiling. Compile means cross-checking and update the model also. Optimizer name is SGD. SGD means stochastic gradient descent. How it works? Row-wise. So for every customer, for every row, weight will be different with a learning rate of 0.1. You know learning rate? Where we have studied this? So here also we use learning rate. You can decide any number. Okay. Loss function, mean, absolute, error. So it's a regression task, guys. You can use any one out of this three. Means square error loss, square log, and absolute. I'm using the first one. Mean, absolute one. Third one. Clear? Now next. Here we have split the data of train and test with a ratio of 80% and 20%. Agree? Now what I'm trying, linear model fit means apply. Applying on which data? Train features and train label. Repeat the data 100 times. Iteration. This one means give me the message. What happening at every stage. And split. Within train, what I'm trying to do, I'm taking this 20% on validation. Train ka 20% is to check validation and test it. Now train is how much? 253 rows is used for training model. 20% of train, which is 63 rows, is used for validation. Whether our model is correct or not. Again, we will check confusion matrix. Time will consume. Okay, done in same. What we do? We apply train, we make model, then we check their prediction, then we check their accuracy. Will consume time, so I've done same. If you want to use test data over here, you can also apply test data directly. Let me run this. POC 1. Data comes one time. How much is the loss? If 2.4 is the loss function, okay, validation 2.4. We keep on repeating the box, and a certain point will come close to. Okay. Here what happened? I need to run from the start. How much is the error? Very high error. What is the threshold for RMSE? Less than or equal to 10. So 22 is not acceptable. I keep on repeating this. Okay. What is the last error we come to the close? 466. Clear. Less than 10. Same way, if you check for validation, also become less than 10 now. Here, instead of doing train and test, I have done train, validation, and test. These are two steps for checking. And we just only one steps, only test. Okay. This I have converted for. I'll explain this point. Okay. If you remember, we have epoch. How many times we repeat? 100 times. Give me the loss of my data, error of my original train data, and error of validation. I just converted this into the plots. PNT plot stress. One second, no? Plus one function remains. Okay, I'll come to this code. There is one line deleted from this code. I'll come back. Okay. Now we have make a model with function of 2.4. Model name linear model. We make a small dictionary called as empty dictionary. In this dictionary, I'm adding a without hidden name. Just a key name. I say linear model should do evaluation of train features and train label. How much we have error, guys? Same way we check for test data. Test features and test label. How much is the error? So we have train also and we have test also. Now this is your entire train data. I just combine train features and train label. Then I say linear model should predict for my train features. And we also get the prediction. Clear. This is without hidden layer, guys, with the error of 2.4. Now let's say if we take hidden layer, what will happen? So we have another model. I can say that. Linear model with hidden layer. Clear. So here I am here also. Okay. Guys, I'm not using dropout now. Dropout will be used in different example. Okay. Def means define a function, make, build and model and combine the function name. What is the parameter name? No. So your data will come. We'll do sequential. So first we'll have input. Then I need to add here with how many dense means neurons. How many neurons I'm adding? 64. How many X we have? 9. So can I say I'm just adding one hidden layer, okay, which have how many neurons? So hidden one have 64 neurons. Clear. Then adding second hidden layer with 128 neurons. Then I'm expecting everything should come in output. How many neurons? 1. Here I use activation function as ReLU. Now what ReLU do? Any number get converted to negative, it will convert to 0. In calculation, for example, this neuron have minus 1.2 less than 0. So this value will be converted to now 0. That's the job of ReLU. Okay, it just convert negative to 0. And output layer is linear. Clear. So here we have taken two hidden layer with ReLU layer activation function, and output layer should have linear. Loss function, mean absolute error, update weight using SGD with the learning rate of 0.01. And the output give me model. I am using just a normalizer for me. Normalizer is a data where we have normalized. We'll come to this calculation later, guys. It's not too important. Model name is what? DNN model. Fit means apply on train features and label. What is the error we started? 22. How much we reach now? Okay. This is your higher train result without hidden layer. Inside this train result, I'm adding with hidden layer, just a name. DNN model should evaluate my train label and train features. Now you tell me which have the smallest error. So can I say hidden layer reduces the complexity but reduces the error? Same I've done for test data. Code remains same, guys. No changes in the code. Here I just change train to test. The same code we keep in classification report. Same here we have. Over here, what happened? The functions are different. Evaluate. These are the function of TensorFlow. Then I'm combining train features and train label to make train fold 2. Then I done prediction for train features. Using which model? Same thing I do prediction for test data. I'll get a prediction for test data also. Clear? Can I say process remains same? Only the way of doing it change. Prior we do with the help of sklearn. Now we're doing with the help of TensorFlow. Inside TensorFlow, we're using Keras. Any question, guys, please ask. अब मॉडल बना रहे हो, ठीक है? How you check the model? You make model on which data? Train data. So can I say we need to check confusion matrix, R square on train data only? So model checking is done on train only. This is a normal process. What I'm trying to do, I'm making model on train only. लेकिन हम ट्रेन पे चेक नहीं कर रहे, एक स्मॉल सा डेटा एरिया उसका नाम रखा है वेरिडेशन, हम इस पे चेक कर रहे हैं. Normal what happened, we build the model on train, we check the accuracy of train, and then this model is applied on test. I'm just adding one more stages. I'm checking on validation also and checking on test also. You can keep 10%, 5%, 20%. हाँ, तो इसने ट्रेन में से ही डेटा लिया है, उसका सबसेट. So I don't give less. Your train subsets will not equal to validation subset. This is a separate concept. Normally we do train and test. I just added validation and test. This way also we do in business. So what happened in business when you start working? Method number 1, you do train, test. Then once your model business accept it, they say do validation also for the next 2 or 3 months. Check the report getting proper, then we go for live. call validation will become your live data. इस पे check करो for the 2 or 3 months is coming correct. Then put the model on real-time website, company website. So here I am doing on everything on same stage. हाँ, well loss correct. वो सीख लिए. ये जो well loss है वो validation loss. जब हमने मॉडल को ट्रेन किया तो कितना था 1.7. When I apply the model on validation data, how much is the loss? 2.3. We are creating also and we are doing checking also. It's difficult or easy. Now, if I need to decrease the error more, so we can either increase hidden layer or we can change activation functions. Why to use reloop? We go for 10H. Answer will get changed. If you want process faster, use dropout. If you want to increase more accuracy, use epoch. So these are the various parameters which play a role of increasing accuracy. Learning rate will have with model prediction. Normally, we do not write equation like this way. Normally, we write equation y is equal to beta naught. ये equation है. Now, in this equation, we need to find best value using SGD. Inside this, we use learning rate. Depends. SQL में करना है तो आपको मैनुअल फंक्शन क्रिएट करना होगा. हाँ, डेफ करके एक फंक्शन बनाना होगा फिर आप यूज कर सकते हैं. इनबिल्ट तो पहला मॉडल किया हमने विदाउट हिडन लेयर, दैट इज अ नॉर्मल लिनियर रिग्रेशन. अगर आपको वेट अपडेट नहीं करना है तो ये कॉन्सेप्ट मत लिखो. यस, if you use this, your accuracy will come more than 90. But what happened? Explanation of to business on pen paper with weights become difficult, and SQL explanation become easy. That's the reason we go for SQL. Okay. TensorFlow specialization happens only for CNN, like artificial data, like image, text data. That time we required answer has to be more accurate. That's the main online students, you can, this is up, the previous batch have done some projects I've shared on Drive for you. You can take from here also as for the reference. Okay, guys, guys, take a break. After break, we'll continue. Okay. Guys, I'll start with a new topic called CNN, Convolution Neural Network. Okay. I'll explain only the concept now. Okay, already we have done Python. I'll explain the concept. You don't have to solve it because here the calculation is 10 times more than neural network. For few rows you have to do, not for all. Clear? Solution file of Excel I'll be sharing. The way I've shared with Naive-based file, same way I'll sharing that file also. Clear? So here we have, guys, what is the meaning of correlation? X and Y. Can I say between columns? What is the meaning of autocorrelation? Between rows. Okay. One second, I'm just searching something. आपको नहीं दिखाना है वो. You will have to see that later. On screen. So guys, convolution name is nothing but correlation. Okay. We have a model called CNN. CNN model is used for working on image, point number one. Okay. Within image, when we need to find a relation, that is called as convolution. Just a name, I'm just giving a name definition. Convolution means correlation between image. Between image means where we have two images now. Clear? Convolution network have three different layers. Within convolution, we have three different layers. First layer name is convolution layer. Second layer name is we call as pulling layer. Third layer name is flatten layer. Guys, in NumPy, I have teach you this flatten one. How many remember? Let me show you. NumPy नहीं पढ़ा हमने, आप लोगों ने नहीं पढ़ा? NumPy package. Column को rows में. That is transpose ना? हाँ, correct. हाँ वही. हाँ कोई बात नहीं, मैं शो कर देता हूँ. इतना कोई डिफिकल्ट नहीं है. Can you see? This is matrix. We convert matrix into single column. Single row, you can say. This is called as flatten. Clear. I just given the names. We'll see one by one what happened. As I said, CNN works for image. Okay. Now, what are the things can we do on image, guys? if you have an image, what we can do? Editing, okay. Editing means changing color. So with the help of CNN, we can do. Second, within image, can we find who is sitting in the image or is standing with there in the image, male or female? So we can do image classification. We can use using image customer or say person identification. So we can identify, we can classify, okay. That is done with the help of CNN. So your traffic cameras, inside that, the server have algorithm called CNN. If you're using a mobile phone, a smartphone, which have Google Photos, if you open that, search for any specific one photo, and you click on enter, it will search for similar all photos. That is clear? That is your CNN model, the live applications. Now let's see. I'll draw the structure and later you have to draw it. The CNN works on image. So first invention of this model occurs in 19th century, 1975 something, okay? And they invented the model to works on alphabets. Which alphabet is this one? A. Can we have this A written on image? So they have taken an image of A alphabet and tried to understand the data. As I said, every image have small boxes. This is called pixels. Inside pixels, data come in array of matrix. Okay, so here if you imagine how many pixels we have. Many. So as your pixel size increases, like 100 by 100 or 1000 by 907, your pixel also increase. Clear? Plus image size also will have impact. We have height and width. Can we have 9 cross 9, 6 cross 9? It is the size of the image. Okay. I'll be opening one file for you. This one second. Okay. 51. I'll copy. I'll paste over here. Guys, I do not write online students because I will be deleting this image multiple times. Okay. Wherever there is a -1, for example, if I take this image and I write A, wherever A is present, over there will be have +1. Wherever we have a blank, we'll have -1. Till you clear? Next. Now looking at this, what is the image over here? X. So wherever there is a data, we have guys +1. Okay. And non-data is -1. What is the image size? Nine by 9. Just cross check, read one time. So this is 9 x 9, the image size. Okay. And here guys, from that image, can we pick up a small part? Can I pick up this part? Can I pick up this part? Okay. The selection means picking sub part of image. And we call this a subset. Small data from image. That subset here we call as filter. I say filter size has to be 3 x 3. Clear over here? If it is 3 x 3, can I say we have this one? Can we take this 3 x 3? Can I say this one is 3 x 3? So I can pick up any subpart from image. Clear? This filter size we will decide. Software will not. Image size we will decide. Clear? Now, when I take a small part of image, just looking at the small part, can you identify the full image? An example. If I take a small part of the image, so you identify now. So half image is also subset now. So either you take bigger size of half set or smaller size, we can identify. Clear? So when you're looking at the half image, you can say the another half. Clear? So instead of taking entire half image, same way guys, what we can do in CNN, we take small part of image, that is called as filter. Logic clear? Okay. Now what we do, as you compare Ronaldo half image and you imagine in your brain another half and you try to map who is this guy. Same way we'll compare filter with all image. Whether do we have any mapping match or not. If it is matching, that is called correlation. If it is match, how much % data is matched? I'll repeat again. The way we compare the Ronaldo half image with another half image of your data. Another half image means in your brain, guys, you already know who is Ronaldo. In your brain, you have full image of Ronaldo with you. Am I clear? Now we have seen half image of this. What our brains do, our brain compare this half versus this entire image. The comparison and exact finding, how much % relation we have, that is called convolution. Clear? So in my case, I have entire X. I just have taken this part of X. This become my filter and I will compare it. Clear? Do you want me to repeat? Saurabh? So we have an image of 9 x 9. From this image, we will select any subset. The subset size has to be 3 cross 3. If I selected this one, and this is second one example. This part is called filter 1. The way I can get first part, can I get this one also? Filter 2. Can I take this one also? Filter 3. So I can select one filter, I can select multiple filter. I'll compare filter 1 with all image. Clear? I'll tell you how the comparison happens and what is the formulas. Suggestion, guys. Draw this image. Do faster, please. The box which I have written now, that is filter 1 selected. Online student right now. Example number 1, you can write hashtag CNN algorithm. Example number 1. You have not written the theory of this. Okay. Done, everyone? Okay. Now, first step is we have an image. Okay. What is the image size, guys? How many layers we have in neural network? How many layers we have in neural network? What is the first layer name? Input. So we have input layer. You don't have to draw this. Okay. We are giving an input. What is the input, guys? X. Which is nothing but image. What is the metric size we have taken? Image size. So we have image of 9 by 9. We have selected filter of 3 cross 3. This filter will go in first layer. Okay. That layer name is convolution layer. Clear? Now we'll see how the calculation of convolution layer works. Guys, this 1 minus 1 is nothing but this data I have taken, okay? Which is colored part, highlighted part, only that box I have written away as a filter 1. Now what I'll do, I'll compare my filter with image. So first I'll start comparison with this one. Just multiply 1 into 1 plus minus 1 into minus 1 plus minus 1 into minus 1. Do multiply 3 cross 3. सारे multiply करना है, addition करना है, and give me the answer. So you just have to do minus. For example, I'll do for one row. 1 into minus 1 plus minus 1 into minus 1 plus minus 1 into minus 1. The way I've done for one row, you have to do for all 3 rows. Huh? That's the reason I say ना I'm doing for one row. 3 rows के लिए किया आपने? हाँ. Sum करें, what is the value? Divide by 9. Divide by image size. 7 percentage. It's a correlation now. 77.78. So this image with this part have how much percent relation? 78%. ये क्लियर हो गया? हाँ. अभी एक किया ना, वेट करो, अभी सेकेंड प्रोसेस अलग है. Here's step number 1. इसको इससे मल्टीप्लाई करो, इसको इससे मल्टीप्लाई करो, सब सारे मल्टीप्लाई करें, सारे एडिशन करो. Total is how much? And divide by 9. How much is the total, guys? Total is how much? 7 divided by 9. Round up to 0.78. Done this one. I am Mahesh. Answer. 9. Now next one. Guys, filter will never change. Once the filter is selected, it is fixed. So what is the image size we have? 9 cross 9. Filter size 3 by 3. Then we take something known as stride. Stride means how many steps I have to move. I say 1. So here first we compare this one, if you remember. Now I have to move 1 step. I'll compare with this one. So how many steps I have moved now? 1 step. Do the comparison and give me the answer. Solving will remain same. Online students able to solve. So the first value you get 0.78. I'm getting minus 0.11. You can see, guys. See. It's here on screen. On screen. First, I compare this box with this box. Now I move 1 step, this box with this box, same filter. Again 1 step. Do for third also. Seven, eight. Second one, you'll have minus 1, 1. Then 0.11. Okay. On screen. Guys, on screen, everyone, you can do later calculations. We have image 1, we compare with filter 1, we get value 0.78. We move one step on the right hand side. We got striders 1. We compare with filter, we get answer as 0.1. Again, we move to one step on the right. Again, we'll compare with filter. Again, I move one step right. Again, we'll move one step right. Again, one step right. Again, one step right. So how many steps are performed? 7. There will be 7 output numbers. Now, again, if I have to do calculation, now this calculation we have done only for one row. This for this cell. Okay. And if I want to do again, I need to go one step down. One step down and again left to right. Then one step down, again left to right. So can I say multiple combinations or multiple calculations? Okay. Now there is a formula over here, guys. What should be an expected output? Now point number 1, what is image size? Filter size 3. Okay. Stride size 1 plus 1. What is output? So the output should be expected as 7 cross 7. Tell you clear. Image minus filter divided by strides. Plus 1 will give you answer as 7. Tell you clear, guys, how we get 7 cross 7. Now the number which we are getting it, same number I copy pasted over here. Tell you clear. 0.77, which you are getting it, minus 0.11 plus 0.11 and so on. Okay. Do we have anywhere negative numbers? Okay. So I'm just doing a color for it for that. Condition where the value is less than 0 in the red. Wherever there is a negative number, guys, everywhere there is a red color for you. Clear? Now within convolution layer, okay, we use one activation function called redo layer. The job of redo layer is wherever we have a negative number, it converts to 0. Negative to 0. Can we say this is 0 minus 0.11? If you can see below, guys, I convert to 0. This is negative, I convert to 0. Clear? So all the negatives has been become now positive for us. Clear? Any question, please ask. Every negative number we convert to 0. And positive number I've same copy pasted. You can compare the last row also, guys. 0.33, 0, 0.55, positive becomes 0. Redo layer concept clear, guys. So when I compare my filter 1 with image, how much percent I have? 0.7. So that cell have 0.78% relation. Second cell have minus 11%, negative relation. Clear. Now next layer we should be adding over here is we call as pulling layer. Clear? Now in polling layer, we have two methods. One is average, one is max. And we decide polling size. I say polling size has to be 2 cross 2. Now from here, what is 2 cross 2, guys? Can we call this is 2 cross 2? In this 2 cross 2, what is the max number? I written 1. In this 2 cross 2, what is the max number? So I have to write 0.33. In this one, which is the max number? I have to write 0.5. Till you clear? I just remove the space between them and written below. So what is the output format now? What is the output matrix size? 4 by 4. ये क्लियर हो गया गाइस? आउटपुट क्या है? 4 by 4. Sorry, हाँ 4 by 4. Any question? Please ask. अभी polling layer complete नहीं हुआ. Just we have make polling layer. The output which I get from the polling layer, okay, written over here. Which poll we have used? Max poll. Clear? Remember we have filter 1. Now again I'll compare this image with my filter. Now what is this max poll size? 4 by 4. So we'll divide with 4 by 4. Multiplying each cell and dividing by 4. Prior we divide by 9 because we have 9 cross 9 image. Clear? Want me to repeat? The way I multiply with 1, I'll move to. That's why I'm moving one step. Because the stride is 1. Again we do same thing. Again we down. Again multiply with filter. Again on the right. So how many outputs we have? First, second, third, fourth. Clear? So this is the output I get from filter 1. So the output size from the polling layer will be 2 cross 2. ये clear हो गया guys? Any doubt you have, please ask because I'm coming to the last steps. Convolution concept clear? Calculation? Yes. पहले वाले? ये कैसा है? ये क्वेश्चन है. इनमें से मैक्स क्या होगा? 1 लिखा है यहाँ पे. हाँ तो इसमें नीचे 1 लिखा है ना. इनमें से मैक्स क्या है? तो नीचे मैंने क्या लिखा है? इनमें से मैक्स क्या है? तो मैंने यहाँ पे क्या लिखा है? इनमें से मैक्स क्या है? अभी इसमें से मैक्स क्या है? सो 2 क्रॉस 2 में से जो मैक्सिमम है वो पिकअप किया. उसको अगेन आई जस्ट मल्टीप्लाई विथ माय फिल्टर and I get answer as 2 cross 2. Is any question on this? Please ask. If you want me to repeat, I'll repeat multiple times. हाँ? Filter change नहीं होगा. One time filter is decided will be there for entire model. Now we have taken how many filters? One filter. So filter one, this is the number. Okay. This number I copy and paste it over here. Filter one by calculation. I just converting this cell on this one, this and this. So this become for me as flatten. I'm just doing copy paste. नहीं. ये clear हो गया. So we have flatten layer. Clear. So can I say we do at the last we have which layer? Flatten. यहाँ पे हमने कुछ concept apply नहीं किया. We just converted into single column. The way I have done for one filter, can you do for second filter, third filter, fourth filter, 10 filters? You can imagine the calculation size. Clear हो गया? So we have done convolution, pulling and flatten. Till now prediction remains. Okay. Okay. To make you understand, guys, I have just changed the filter number. Okay. I'm repeating just to understand. I changed the filter number. Clear? Okay. Filter number one. What is the first cell? One. I'll write over here. Second cell. Third cell. Fourth cell. One. So can I say we just converted this into flatten? Same we'll do for second filter. ये clear हो गया? Guys, any question? Image X concept clear? Can I say in image X we have taken three filters. All three filters will go through convolution, will go through pulling, will then become flattening. So now here we are working on the concept called as image classification. When I say classification, guys, what is the meaning of this? So we have more than one level. So let's say we have a training data. In training data, we have two different images, X and O. We have done for which image? X. Same way can we do for O also? ये clear हो गया? How many filter we have in X? 3. So how many filter we will have over here also? 3. ये clear हो गया? Logic clear, guys? So same way I have written for my X also, O also. Need to repeat this? Guys, don't talk. 5-10 minutes, please. हाँ randomly लिया है. जो filter आपको लेना वो ले सकते हैं. Here we have X and O and our filter are ready. Now we will take our live data, or we can say test data. I'm passing an image called as V. I want to compare my V is similar to X or my V is similar to O. The way we have done for X, same way we have done for O, same way we will do for V. ये clear हो गया? Comparing X with V. Now X is my train data, guys. Okay. And V is my test data. My question for you in filter 1 of X, where we have the highest value, 1 with the position 1 and 4. Guys, position is very important over here. 1 and 4. In filter 2, position 1. Filter 3, position 2 and 3. ये clear हो गया? What is the sum of all the numbers? Sum of all ones. This plus, this 2 plus, this 2. 5, okay. Now we have to work on data. Now we will compare position. Filter on which position we colored? 1 and 4. The color same over here. Filter 2 where we colored? Filter 3 where we colored? What is the sum value? Okay. So let me write for you. The value of X is 5. The value of V is 4.56. Now we'll find same way value of O and value of V. In O, where we have highest? 2, 3. Then next. In second, do we have? They are equal. So we will not take from you. From the third, 1, 4. Same. And do the sum over here. What is the answer? ये clear हो गया, guys? We'll compare position of O with position of V. See, I selected same position wise. What is the value now? Now use your mobile phone and give me the ratio. 4.56 divided by 5, 2.07 divided by 4. 0.91. 91%. Which have the highest percentage? So we would predict that X value, the V value is similar to X data. This is called image classification. अगर आप देखोगे X का half part is V. Take from any angle, no? So here we can say 91% chance that image of V is similar to X. So we will classify V as X. Clearly. Okay. 1 second. It's not completed. Here we get something known as output layer. Can I say here we just have used convolution layer, pooling layer, flatten layer, and output? Do we have used anywhere hidden? Hidden layer? No. If you want to use hidden layer, in hidden layer, what we have? Hidden layer have neurons. So I'll write hidden layers. H1. Can I say flatten layer is a one single column? We'll go data over here and there. And then we have output layer. Guys, hidden layer calculation I have teach you. Weight, bias, neurons, cell body, activation, prediction. हाँ, जितने फ्लैटन हो गए, अभी यहाँ पे हमने कितने फ्लैटन लिए थे? 3. एक फ्लैटन में कितने 4 रोज है? So 12 3 is 12 4 3 4 is 12. How many input we have now? So starting from here, if you do till here, this is called CNN. Starting from input, if you do till over here, this is called fully network. CNN itself is artificial model. So half is CNN. If you take hidden layer, it's become fully connected network. Guys, any question, please ask. हाँ, एक बार आपने लिखा 3x3 and you say I want 10 filters. Every filter will have matrix 3x3. आपके ऊपर है. Depends on you. If you're okay with 2x2, go for 2x2. हाँ, ले सकते हो, आपके ऊपर है, कैलकुलेशन है ना सर. How many layers I have written over here? Convolution, polling, flatten, dense. I say it's a sequential model, guys. पहले convolution, polling, flatten. What is the filter size? How many filter size? 3. Stride means steps. How many filter? हर filter में कितना matrix size होगा? 3x3. Image size क्या चाहिए हमें? With 3 colors. Activation function, layer name, convolution. हाँ, 3D भी होता है. अभी ये क्या है? Polling size. What we have taken? Which polling we have used? Function. Okay. Then we have flatten. Hidden layer. How many neurons? Second hidden layer. How many neurons? Output layer. 1. Okay. This is concept. This is concept. This is code. The way we have done the concept, same way we have to do the coding. Draw करो. Fully connected network. नहीं, कैसे कुछ नहीं. Okay, this is for any people want to study for any high level. Example, you want to study something on CNN. I press enter. Remember, you have seen ECG report? ECG is an image report. Okay, they have applied CNN. We have the cycle marathon. In marathon, guys, people who drive cycle, they get thirsty and we have to give water bottle. So question comes, where to stand, how to stand. They identify the position. In F1 race, we need to fill the petrol very faster. That's the reason prior we used to fill like this way, now we used to fill like this way. Object detection, high quality object detection, instant segmentation. This is a very good paper if you want to work on only on AI. They will not teach you deployment this paper. For example, let's say I want to work on cancer. Okay. Everything. Cancer detection, video, audio. Just click on cancer. Okay, I click on this data. Okay. Breast cancer data set. Okay. They applied this model on 10 Jan, uploaded, accuracy of data set available. See, data set also available. Code is also there. GitHub links. Research paper, compare all the models. If someone have done same data, but multiple models, they will give you comparison also. There are models who can give you 99% also. वो मॉडल बेस्ट है तभी तो आपका मैंने KNN मॉडल सिलेक्ट किया From my side for today done. आज के लिए इतना ही. You don't have to go home. Log into your drive. Point number 1. Okay. Half an hour we have. Log into your drive. Download the file. File is 200 MB file. Okay. You have to download, run the code, getting an output, you can leave. Otherwise, you will come tomorrow, you will run the code, will take 1 hour to download, half an hour to run. I'm uploading once again. And students, guys, done for the day. Okay, guys, code is also uploaded. Data is also done. You can download. हाँ, download करना है, unzip करना है. Online students, you done for the day, guys. You can download the file from the drive and just run the code.